Thank you, man. All right, it's all yours. Take it
Okay,
away.
so I'm Chuck Wolber, Gabriele Paoloni. First, I want to make some remarks about the intent behind here. So I think, in my opinion, Alyssa should not be exclusively focused necessarily on safety, but sort of like how they use the term racing improves the breed, right? All the automotive companies, it's marketing, but also they learn a lot about materials and all that kind of stuff. When we press things into service and safety, we learn a lot about the way things work. If we took the same degree of rigor that we apply to things we get quickly, like cell phones, to airplanes, you'd probably get your $100 round trip. I said this in the introduction, $100 round trip ticket to Paris, first class, but your probability of returning home would be like 50-50, right? A lot. Same, and it goes the other way around too. If we applied the engineering rigor we do for the highest levels of criticality on general purpose software, your phone would cost $1 million and it would take 15 years to get the latest version. So it's impractical. So my intent here, I won't speak for Gabriele, he speaks for himself, but my intent here, my motivation here is to thread a very delicate and extremely narrow needle to do something that brings those two worlds closer together. We improve software, open source software, targeting the Linux kernel first. At the same time, we speed up how fast we can do things in commercial aerospace. Now, I am not a system engineer. I don't want to misrepresent my capabilities. I have hung around with people who do fault tree analysis. I have heard numbers like 1 × 10⁻13th is what we're shooting for here on a commercial airplane. So that's like, you know, billions of Powerball lotteries winning that one, right? That's how reliable we want to make this stuff. So that's just impractical for a lot of environments. So, but here I think there are some opportunities. One last thing, my colleague Steve Vanderleest wrote a really good paper. Find it. It's been published in the Digital Aviation Software Conference called Avionics Linux. It's with IEEE. So if you have institutional access, you can get it. If not, you can email Steve. He'll probably send you a copy. That lists out all the what he calls the grand challenges required to get Linux in the highest areas of criticality. This is shooting at one of them. Okay, there's a whole bunch of others, but this is shooting at one of them. It will fixing. One other thing is I don't know. I am pretty sure commercial aerospace is the highest degree of engineering rigor, but I still would like to hear more from the degree of rigor required in medical, nuclear, aquatic, all those environments. So I hope to anybody else listening that if you are an expert in those fields, that you'll come to Alyssa and let's find where the greatest degree of rigor is and let's shoot for that. Okay, so with that preamble, let's start with some terminology to make sure we're all on the same page. A bug is a violation of expectations. We're kind of taught this in our first foray into computers. I understand that you probably recognize I'm making an assumption that the hardware is working correctly there. In this case, let's define a bug as just a violation of expectations. So therefore, a requirement is your expectation in a testable form. So you could formalize a developer statement of testable intent. That's your expectations, or a violation would be the bug. Or you can shorten that to testable expectation would be your requirement. Testable, we want to talk about the difference between positive requirements, shall, you can prove the requirement, shall, or untestable, which is unprovable or not reasonably proven, right? I can't ever prove something is 100% safe. I can't ever prove anything's 100% secure. That's not a reasonable thing to ask. So there's testable and untestable. Your design is your decomposition of your intent into pass, fail, testable form. And a lot of people say, well, what's your design? I might show you a document. I might go on and on and on and ramble on the whiteboard and everything. But truly, if you're going to really decompose your design, you're going to start from your big idea, break it down to testable form. Yeah. Steve.
Yeah, for design, I mean, that almost sounds like almost the interface or API, like what you expect. It's almost like the design. You can say, is it the it's being designed for implementation details?
No, your design is the description of your implementation in testable form. So if I say go do X, could be a kernel module, could be anything. The design now is your description in testable form. The degree of rigor I want to apply to it maps to where I'm going to use it. If it's going to be in life safety critical, transporting patients to Harborview Medical Center, tier 1 response, that kind of thing, then I'm going to apply a lot more rigor to your design. I'm going to expect a lot more detail in your design than if it's going to go on someone's cell phone. So that's what I mean by you want to decompose it to the degree that I need to know to be safe and comfortable in that environment. And so when we talk about decomposition, we're really talking about big ideas broken down into smaller ideas. And you can just replace the word idea with testable expectations. So I want a airplane that flies 500 people, 10,000 miles in comfort. That's the big idea. Break that down into probably billions of tiny little microscopic expectations down at the bottom. All of those being testable, now you can test your design all the way up to the top. At the very end, you say, yes, I have what I expect. I have a safe airplane that carry all those people. So at the lowest level, and that's at the highest degree of rigor you need to apply for the most danger potential hazardous environment. From DO 178C, we see that it says software requirements from which source code can be directly implemented without further information. In other words, I can lock you in a room, just hand you this small amount of text, and out will come 100 people. I can do that separately isolated, and 100 times they'll come back. Maybe the variable names will be slightly different, but the implementation will be exactly according to what I've done. And if it varies, then that means I did not specify a requirement low enough and more detailed enough. So what we're talking about here in this particular case for this proposal, and by the way, the proposal, we're still working on it. This is a proposal. I wouldn't even call it beta at this point. Okay, we have to road test it.
And you want to do this for Linux kernel?
Yes. Let's continue.
More detail on that.
Yeah, more detail on the next slide.
Untestable.
Uh-huh. Okay, the other thing is I have the same level of hubris and perhaps arrogance that Linus did in his dorm room, thinking he could create a professional kernel or that kind of thing. I understand that's what I'm saying here. I recognize the hubris in my words here. But you know where we are with the kernel today. I expect that if we do a good job, we draw people in, we can use in aerospace and all these other environments, the Linux kernel in the highest levels of criticality, oddly enough, I think it'll happen. Okay. I'm probably dumb enough to think it'll happen. Okay. It did once, maybe we can do it.
Parts of the kernel.
Yes, of course. I'm certainly not suggesting tomorrow we're gonna, yes. I'll probably be long dead before we get right. Okay.
We can sleep about MediaTek drivers.
Yeah, right. Where do you begin? So if you want bug-free code in 3 simple steps, you just document all your expectations. You write a pass-fail test for every single testable expectation. You validate the test with code coverage, right? If you have a test and it doesn't cover all the lines of code, you need to better document your expectations. Lather, rinse, repeat, and profit, right? So it's just that simple. It's just that easy. So this is Alan Turing on his little horse spewing out bits from his class. There you're in. It's about as realistic. I think he should be the mascot, honestly, for this project. Yeah. Oh yeah. I put my prompt. I said I put my DALL-E prompt down here, so maybe you guys can see if you get the same result. But I recognize how crazy this is. But we want to use. First of all, the Linux kernel and open source nobody disagrees. You want that level of rigor for the reliability. No one wants to pay the cost, and we want to take the Linux kernel to the highest levels of criticality because we can do more stuff, right? We want to speed this along, and everybody wants their $100 ticket to Paris. Okay, all right. So let's talk about kernel design expression. There is no testable design expression. It doesn't exist. There's some really great documentation. I actually enjoy reading it. I told Jonathan that, and he looked at me strange, but it is interesting documentation to read. It's very well written. He did a good job curating it. It's pretty well organized. You just grab the file what you want. But the problem is there's no testable design expression that exists. And that which is testable, there's no evidence that there's alignment to developer intent. I can't check to see that the developer at the very minimum said, yep, that's what I meant. Now, we're all smart people. We can make an educated guess on 2 + 2 = 4. If that's what's in the function, I understand that, but the Linux kernel is a very complicated place. And looking at a function, I know we've all puzzled over those functions, even though it's plain speaking right in front of our face. And you still don't understand what it means, right? There's a lot of polymorphism. speaking to where the architecture working group has been going, we cannot reason about design while we're still guessing at intent. So the idea behind this whole idea is we want to express the intent in a way that's a lot more understandable, a way that lends itself to that is testable. So at the 2024 Linux Plumbers Conference, we've been working on this for a while. But that's when we had the conversation in front of, I guess, an audience of kernel developers. Steve, you were in there with us.
Like 2 other people.
Yeah, yeah, there were others. Thomas was there. Thomas was there. And there was general agreement that all the details I've been talking about, this is the case. We do not have testable intent. Design expression does not exist in a testable form. We can't reason about design while guessing at intent. We need some sort of, we need to include that with the code. And it needs to be some sort of machine readable template because you can't compile English language intent. And therefore, you know how there's that rule where you can't include commented out code because it just drifts. You don't know when it was relevant or if it even compiles. You have to get rid of it because it can be super misleading. You can't compile a description of intent. So you have to have the ability use tools.
Okay, so to bring it back to the
Yeah.
original side by
Mhm.
the API.
Mhm.
Because there really needs to be, it's not just intent, like, well, yeah, mainly intent.
Yeah.
How do you document that? Because the main issue I'm afraid that this can cause is, say you have a bug in the code
Mhm.
and you make the design have that bug as well. How do you catch that?
Well, that means, so if it's a bug, it's a violation. So let's start from the beginning, first principles. If it's a bug, it's a violation of expectations. Therefore, then you would look and you'd say, do I even have I even documented that expectation? No, because the kernel's massive. And the answer is probably going to no for a real long time. Okay, well, then then we need to document that expectation in the form of a requirement, fix the code that causes us to vary from what our expectation is. Then hopefully, someone can write a test against that plain English explanation.
So going back to like some of the Dave Bristlett's work,
Mhm.
where he kind of, he proved the scheduler to be
Yeah.
correct by starting up the design of saying, this is what the scheduler is supposed to.
That's
do.
his expectations.
Yes, the
Yes.
expectation, and then he
Right.
wrote the modeling software.
Correct.
to Go through and model it, found 2 bugs in the process,
That's right.
but, that,
So then you would want to document all those expectations and then do the obvious work that he did to go forward from that. And that's how you express your design. Just like that.
That case, then the model, expect to give, right? So,
Yep.
yeah. But here, I don't think we can do a formal model, that did a formal model of the schedule, right?
but without that, how can you prove this?
Not everything is formally modelable. Some of it's computational and tractable. That's why we have what's called modified contingent decision coverage, all those things to get around the tractability problems. Which we can get into.
So here we have kind of reason.
Yeah.
That is like, what Daniel did is like, top shooting for the,
Yeah.
is it big, like, top.
Yeah, that's the other disclaimer I should have preamble. It's like, we are not looking for formal provability. There's not enough energy in the universe to actually do that. It's too many variables. We'll solve Bitcoin before we do that. The template has to, so I was getting at the template has to be machine readable because you can't compile English language requirements. The reason why we want people to remove commented out code is because it diverges. So you need some sort of machine readable template that allows you to trace, has this, if the things that are affected by this requirement, I'll go over with how we did the criteria. If that's changed, I need a tool to tell me I need to review this requirement. On top of that, I need to then show that review has occurred. That way I don't have semantic drift between the description and what it represents. So, and then the idea would be, like I said, I know how crazy it is what we're proposing. So then the idea is those who need it most will help to contribute as well. If we build the framework that allows the sandbox to have people come in and play. That's the idea. All right, so these are we're working on a paper, so there's a lot more detail in it. So we're just giving a rough overhead. These are some of the requirements that we've come up with. Mostly aimed at, like the first one, we're not trying to create a process step, getting the code into Linus's tree. That's not what we're trying to do. There is a complementary maintainer path where the developer can say, yes, that's what I meant. okay, well, I'm the expert, not me, but I'm the expert writing the requirements. That's a separate maintainer path complementary to the developer who says, no, that's not what I meant. This is what I meant. Okay, well, let me put that in requirement Ds for you. Each requirement needs to have a stable ID. Each requirement has to have a hash key. That's what I was talking about, detecting when criteria changes. Hash keys and the stable IDs, there's some criteria here. But the big one is you can't have central coordination. That is a DOA. You can't have any central coordination. It's got to be reproducible. So I should be able to take a source code release without the Git repository. I can't see any of the history. I should still be able to run the tool and say that requirement's not up to date. The criteria does not match that, well, hash, right? So therefore you have a problem. I don't anticipate you're always going to have Git or even know the history. So that the template should tell you what you need to know. And then template should be embedded with relevant code. That was my biggest surprise from that discussion. I think even you and Tomas were like, no, keep it as close to the code as possible to ensure you have that. So these are some straight up template format.
Is the community gonna go for that?
Well, that's why I'm not this proposal and we're working towards it, and it's why we have. It's not 1.0 yet.
Okay.
Okay. So it needs to be obviously machine readable, also human readable, so you should be able to see it.
Kernel doc.
Yeah, it fits with the kernel doc. It would be, you could see it in line with all the rest of the kernel doc.
For core kernel code and for like certain things that we care about, I think we can push this as a requirement. I mean, for like any little module or maybe side project or little off things, this is only stuff that are, it's going to be in the path of safety critical code if we want this. So other things, there's not gonna be, it's not gonna be a
Well,
kernel thing, but
50% of the kernel drivers, right? So.
Yeah. Actually, it's what, so we don't really care unless the driver is going to be in space
And I think
or
I think there's the ability with this template design, there is the ability to, if someone just objects to a giant blob in their code, there is the ability to offload to like a sidecar file.
Yeah.
There is that ability baked in.
But I don't know, like I said, they'll become useless if we did that.
Agreed. And so we need to find where the
Right.
thread the needle is.
Yeah, we'll never do this with the I-915 driver.
My criteria for success here also is, 70% I need the community to adopt it. And if I have to compromise on that, that's better than getting everything the safety world needs. We need to go forward and get something out of this. So that's what I'm hoping. Everybody wants to see more reliable kernel anyways. The other one is I want to see this standardized through SPDX. It needs to have some ownership of the design of the template so that other projects and institutions who want to contribute back requirements know that there's some rigor and weight behind it.
So question, this gets into the kernel.
Yeah.
Who would, I mean, is there going to be an organization or whatnot to constantly check that these requirements match and give reports and everything else, like a time?
Yep, that's baked into the design. There will be scripting and,
Okay. Because,
Oh, yeah.
Because once you get this is where you get buy-in from the community.
Yes.
If you go in and they say, hey, I found, if you report actual bugs in someone's code because of the design, or because of these robots, people say, oh, this is useful. I mean, when the Zero robot first came out, I was one of the first people at the Kernel Summit to say, this is awesome. And people were being pissed off at these emails spamming saying your code is busted. And
no, we need that.
what?
We have, well, you're right, we need that. Yeah.
When first,
Yeah.
the 0-day robot, when it first started, people were complaining about it, seriously, but they didn't realize, because sometimes it found bugs that were so, what's it called, vague, that they didn't believe it.
Mhm.
And I looked at like, guys, this is an actual bug, go fix your code. And it took probably a full year and a half before people said, this is a good thing.
That's why the design of the template is such that I'll be able to tell when the criteria changes. Now you need to send something to look. Go
The
ahead.
change of mind, right? To make sure.
Yes.
You need to.
It take about a year and a half or so to get
Well,
acceptance. After
Gotta
showing-
fight false positives.
Yeah.
This kind was just a bunch of code, then we get it wrong, Yeah, it's not a mechanism that along each submission will raise flag of which requirements have to be reviewed.
But the key thing is, let's make sure that we don't get false positives, because if you want to kill a tool, that's what kills it.
I have criteria. We can take a look at that.
Yeah.
Yeah, I have criteria. Yeah. Okay, so these are the currently proposed tags right now. Prefixed always with SPDX rec, so you can do a nice simple grep -r through all the code and get an entire just formal, not formal, but document of all your requirements. That was the intent behind that. Entity relationships, I'll go into more detail on the actual proposed tags. These are the ones so far. And then the line format, so every entry is just tag and string. I put a regular expression there if you want some rigor. And we'll talk about these here in a second. Saying all characters are UTF-8, which is backward compatible with ASCII, which everything should work fine. Trying to keep it simple, no text processing escapes or variable expansion in the strings. It's not the intent here. Try to keep to the common sense rule, 80 character common sense rule. And then preserve leading white space, trim your trailing white space. Just it's kernel patch submission guidelines. So the TBD stuff, we'll talk about where this is going to apply. Grouping would be to say certain tags like the requirement text and a note, which we'll get to. You might want to group sections of that. You might want to enumerate that. There might need to be for a particular instance of the template. You might actually want to include 4 or 5 or 6 requirements in there to accurately describe. And I have an example of that. So these are things I've highlighted that we have to take a look at. Offloading would be saying, we're going to get too much pushback. There's just too much comment, too much kernel doc in there. Let's be good neighbors. You might want to offload some of this to a sidecar file if necessary. So I don't know where the happy medium is. I just want to highlight that nobody's ignoring those things. We need your feedback to tell us how we dial that in and get just the right effect here, how we titrate, get the right value. And then the other thing we come up with here. Okay, so the requirement ID would be the first tag, usually at the top, has to be at the top. The intent is your stable tracing. From a design standpoint, starting from the big idea at an OEM, like Boeing or Airbus or something like that, this all traces down formally until at the boundary layer between the OEM's work and then the open source work. That's where you would attach to. You would attach on that stable requirement ID. That way I can just trace from the big idea all the way down to the lowest level of the kernel code, ideally in the perfect world, and get that. There's mandatory one and only one. And the string, I've got a proposed hash generation method. We'll talk about that. And this string does not change over the life of the requirement. One important reason for that is one of my colleagues pointed this out in my original design. I didn't have that. If I update because of the hash key method, that's actually going to ripple on through and force everybody above it that's generating their hash. So it won't work. So you need a stable ID to avoid that problem. Okay, the hash key is what you use to create tooling automation to tell you either check-in time or later on, if someone doesn't want to update the requirement, that you may potentially have semantic drift between the description and the requirement and the actual implementation. So that's what the hash key is for, to signal you when you have potential drift. Someone could have just fixed a spelling error and there's no change, but in addressing that to make the automation stop complaining, you do update the hash key to say, yes, I've acknowledged the change.
So you're hashing the code?
It's a criteria. The code is one criteria. So there's a set of criteria. I'll go in here in another slide. But there's a criteria, a proposed criteria.
I would assume that spelling changes or something like that, or even variable name changes should not affect this. This should, if you think about it.
You would think. You would think. You would think.
Well, spelling change in code.
If it's not change the behavior of the code, just by behavior or documentation.
I can point to places where changing a spelling error changes behavior. So
Really?
yes,
Oh.
absolutely. Yes.
That's going back to the part that you.
When a human is reading a screen and a safety critical
Oh, yeah,
event and a
yeah, but-
spelling error causes them to do the wrong action,
Within a string, that's a variable modification.
Right.
That is
that could have a safety effect.
That is not considered a spelling change. I'm saying using comments or variable names. That's what I'm talking about.
Yeah.
A string is data.
Yeah.
So
Yeah, yeah.
I understand.
modifying a string, that's a change of the actual code.
Correct.
I'm saying is that it shouldn't, like, well, you said spelling error, all the spelling error checks and patches I get, 99% of them are not in strings.
I understand. A lot of that is no functional effect. And I understand that. The point is not to say, I'm going to design in so much complexity to this template the tool's never gonna trigger when there's no functional effect. That's impossible.
Oh, wait.
That's intractable. So all I'm going to say is the hash key is alerting, the change in the hash key computation is alerting you that you need to check this. And then if there's no functional effect, great, just update the hash key and put that in your code commit
It
saying
sounds like,
no functional effect.
like the compiler. I mean,
Yes,
basically, if you look at
exactly.
it outside of the compiler, I mean, a lot of times, like, you can make changes to variables, all that, the compiler.
But the binary is still the same.
Binary is exactly the same.
Exactly what we're searching for here, right?
That's, yeah,
Yes.
that's what I was looking at.
Right. Because we don't have a way of compiling English language requirements and saying, oh yeah, it still tests to the same value. You gotta have something to alert you a change is here. You look at it and go, no, it's a useless spelling error. It doesn't matter. Just update the hash key.
You can use the compiler to detect if there was no code change.
Correct. We don't have that ability with, we don't have the ability to have a compiler to say the code has changed and the requirement needs to be updated. We don't have that ability. So we gotta have a hash key to say, you need to take a look. The human is the compiler in this.
Or just compile the code, look at the objects. If the
Oh,
objects.
three people. Yeah.
I think we need to take this into consideration. It's actually some proposal that we do.
It's not that simple.
I want to explain, if you trust the compiler, what happens if the compiler has a bug? You know, it's complex, not so
Right.
simple.
Right.
No,
What, all I'm saying is when the criteria changes, it doesn't mean anybody needs to lose their mind. It just means a human who wrote, someone responsible for the requirement needs to take a look and say, is the requirement affected by this change? You can see the patch, you can take a look, pluses and minuses. If it does, then make the change in the wording. If it doesn't, don't make the change in the wording. In either case, the hash key gets updated saying it's been addressed. I've checked.
I'm sorry to ask.
Yeah.
Your thought. But now also think about the compiler, maybe in the future, you guys would work compiler guys. And then tag like, hey, my code works with this compiler, with this version, this commit, then in this version, is trustable. So you can have even ID linked, like you can trust your code, this compiler version, with this hash, etc., etc. It can be a chain of trust.
So aerospace has a standard for that. It's called DO330, tool qualification. So if you want to take credit for what a automated tool does, and a compiler is an automation tool automation, then you can use what's called tool qualification level to qualify the compiler. It's a whole nother thing. Then you can say, I'm just taking credit for what the compiler does. Most of the time, what you do is you say, I'm not going to bother with that. I'm going to test the result, use code coverage tools and all that to make sure it complies with the expectations. Then I don't have to worry about what the compiler did because I'm already testing its output.
Exactly.
That kind of thing. So you have multiple choices there. There's several choices. Okay.
Thank you.
Yeah. Any more questions? Okay, then you have traceability. So there's a traceability tag, SPDX rec child, so from parent to child. If you want to go the other way, it's just you can rep through the code and figure out your own reverse mapping. This will just be a requirement ID that's not cyclic, so it's got to be acyclic of another requirement if you need traceability. So OEMs would definitely trace down, right, into the child requirement, into, you know, the surface area of the kernel all the way down. But there will be a lot of times when an idea in a kernel is decomposed through several other functional means. So you want to trace through that. And that's another reason why we have to have the requirement ID be stable, so you can ensure that tracing doesn't necessarily ripple back. If a child requirement is updated, it's important for the person analyzing it, say, does it have an effect on the parents? And the tools can tell you, you might want to check these parents as well. But like when Linus says that your patch is touching code you shouldn't be touching, right? This would then be able to tell you, you might want to take a look and see the effect on those parent requirements. Not necessarily. Okay, so the hash generation method. I spent a lot of time thinking about this, had this reviewed from other people. I'm not promising this is ideal, but I started from a thought experiment. If we take the unrealistic and laughable idea that we have a perfectly architected, perfectly documented, all the expectations documented kernel, okay? Then we say, if I make a code change that calls into question now that perfection, what things could change? Remember, I'm starting from a perfect, theoretically perfect place. And I say, I'm going to make a micro change that potentially perturbs that perfection. What is the minimum set of things that I should be watching to tell if I need to signal somebody, you might want to take a look at your expectations now. And the ones I came up with were the project name, the file path you're in relative to the root of the repository, existing requirements, okay, minus obviously your hash strings, of course, and then the actual code itself. This is kind of a straw man bash command line example. You just basic concatenation, shove it into SHA 256 sum, and you get your hash. That then you can use it as your requirement ID, definitely your hash key, and then your tool would then just iterate all through the kernel code, check these criteria, generate your hashes, and see where things match and don't match. And then that's when you're alerted. Or when you're checking your code in, it says, well, here's your lines of code. This is the nearest requirement. Let me check. And you can get an alert if your hash key, if you need to review this, you need to check. I think that's what we need, but I'm not promising. Maybe there's other criteria, but I was just looking for the minimum criteria necessary. Hopefully in a perfect world, eventually we will have that perfect architecture. So that's the minimum criteria. That's all you need in that case. So comments, questions on that? Yeah.
Is this gonna live like in the Git repo somewhere?
When you say this, could you be more specific?
Yeah, like this information, is it gonna be,
Oh, this is why I wanted a standardization effort with SPDX.
okay,
So then that's the,
that's weird.
at least we can revise the standard later, but this is the revised standard of you use SPDX template. This is the hash generation method that the committee has agreed to adopt, et cetera, et cetera.
Are there gonna be thousands of these 16 byte hexadecimal strings loaded through the source?
Yeah, I'll show examples of what it looks like.
Okay.
I'll show examples. Yeah.
There can be cases where you have a requirement that is mapped to implementation that is scattered around
Yes.
hundred of files. So the code here is not just.
That's why we start from a theoretically perfect, the thought experiment allows you to derive the minimum criteria so that as you build up your design, your expectations and your design and all that, you begin to approach that level of perfection. Then you can look at it and say, that is the only criteria I need now that I'm now approaching that level of perfection. I don't need more.
The code is inside some other.
Oh, you asking how do I tell what code is proximal to the requirement?
Yeah, the code is defined somewhere. In the-
Yeah. Yeah, I have there's two mechanisms for that I'll talk about, how you determine proximal code. Okay, so I'm sorry, go ahead.
Yeah, sorry.
Yeah.
So, because the project is very important.
Yeah.
My opinion.
I hope so.
We
I think it is.
We should adopt this as a open source community.
Yeah.
How easy it is to start using? Like, can I just git clone, clone and then run like hey, transform this repository in something documentable that your tool can generate for us?
I mean, you could-
Today.
We haven't written any tools against it because we haven't, there is a general agreement on the template format.
Okay.
I'm seeking responses
Okay.
and feedback. I don't profess to be perfect, so. Yeah. But yes, the idea would be then, we'll have that eventually.
Do we look at the next step?
Yeah, we'll show next steps, yeah. But the idea would be, let's say you're a non-kernel and oh, this is great, I want this for my project. Yes, there would be my hope is that SPDX would standardize the template. We'd have probably some minor amount of reference tools, but my hope is the open source community would just scratch that itch in various places and say, here's a bunch of SPDX relevant tooling. One of them I imagine could be just stub out all of the functions in my code, give me a guess at what I'm missing tools. I hope a huge ecosystem will erupt around here.
Yeah.
The intention from these requirements is to be able to pull them out and create formal documentation from them. So you're going to need some sort of a connection to the past, like a subject line on an email. So SPDX Rec Sys was chosen to say, like for the Linux kernel, it'd just be the first relevant subsystem. Other projects can decide what they want. When you pull the requirements out away from the code, you're going to need a tiny little clue what subsystem it came from or however the project wants to regulate that. You always got the rec ID to trace back to the actual code if you want to have perfect connection from it. But regulators love to see documents, right? So you can grep -r and pull out all your requirements that way. Any questions?
I'm waiting for the examples.
I'll show you. Don't worry. I get to. Okay, generally the expectation is, this is an optional tag, SPDX rec lines. The code relevant to the requirement will be just proximal. So you could have the requirement template up here, implement instantiation here. There could be a lot of comments, finally compilable code. It'd be the compilable code in its recognizable block. So like a function, whatever.
Sure, I'll ask if you can take change logs into consideration.
Let me address that. So there's a reason, yeah, let me address that. That will not always be the case. And I have a suspicion that as we get into detailed requirements, the kernel wasn't written with design in mind, testable design in mind, not like this. So when I've taken a look at some functions, like, I think it's going to require a lot of sub requirements to describe that function, which would mean we may need to have some ability to localize relatively speaking, like this function applies, or this requirement applies just to those lines, so on and so forth. This is I'm suspicious this will be needed. I hope it won't, but we have to do more testing and try it on various areas to find out if we need it. And it's a relative, so yeah, go ahead.
For my experience now, the lines, this is just like a end condition.
A what?
The way you have described this line, so just an end condition of a complex problem. We made a pattern in Trinidad about requirement. So about automatically tracing requirement from code coverage, so stuff like that.
Right.
Well, then all of them, simple end condition like that is not applying to the case. So you probably need to support a more complex logical.
We need to talk. That's what I was afraid of. I kind of suspected that'd be the case, that the devil's gonna be in a lot of details here. Yeah.
First of all, I'll knack that right away, the
Sure.
requirement lines. Lines is a horrible way of pointing.
Relative lines, by the way, not just,
It doesn't matter.
yeah.
No, what we do is like if it's function, like they say like inside a function, there's a requirement done.
Mhm.
Just, you're gonna have to have a comment and a tag around that function.
That's fine.
Start and end.
Yeah.
That's it. But you're not, please don't use lineups.
That's fine. I'd be happy to knack that. I don't like the idea anyways.
Yeah, the second numbers are going to be impossible to maintain.
No, well, be careful. I'm not talking about actual line time, I'm about relative line.
Well, even relative.
Yeah.
Like that, you have to add it like.
I agree. I'd love to knack it. And so with that, I will knack it. So thank you. Yeah.
Well, okay, I'm gonna add on to that.
Sure.
I hate lines also.
Yeah.
And I don't know about putting comments in either. I don't know if comments is gonna be that desirable depending on how many of these you have to put in.
So
Could
actually.
you put line, some kind of expression that matches the beginning and end of the block?
They just put a block saying this is, okay, so one thing I actually love.
All right, hold on. Let's not get into design.
Yeah, we don't need.
Let me finish. I want this conversation to occur, but lunch is here. Yeah, let me quickly speed through the rest of these and we'll talk all about it.
Yeah.
Text is obviously the requirement text, human readable. It's gotta be human readable. Get your formatting out of there. I don't want to see it. Complies with requirement, definition best practices. That is something we can spill millions of gallons of ink on. So I'm not gonna get to that here. It's got to be detailed enough to support blind re-implementation without additional information while avoiding pseudocode like repetition. Okay, notes, that's just gonna, that's common in requirements where you close down invalid avenues of interpretation. It makes it so you don't have to write impenetrable legalese. And then multi-line tags. The idea is to make the simple case, the common case really easy. Just take all your SPDX rec lines and just take the text portion and just concatenate them. But you might need to have like, you might want to have like ASCII tables. That's actually common in requirements sometimes. So I just threw a little provision in there here to say, I intend for there to be a new line at the end when you can concatenate this. Beyond that, I'm hoping maybe with there, I may have to add some enumerators, that kind of thing, but otherwise, that's what I'm hoping is the minimum. I want to get to Shua's questions because these are really good ones. Here's some examples. Let me address Shua's questions first of all. So the change log, discussions like this, papers, conferences, all of that is the vapor of nuance. Okay. We have to condense that. So Neil Stephenson, my favorite quote, my favorite author, Neil Stephenson says, condense fact from the vapor of nuance. Okay. All of those things that we described, tons of things, all the discussions, always everything, you have to condense that into a testable statement of intent. Nothing like that exists. Not only is a testable statement of intent, but a testable statement of intent that the developer agrees accurately reflects the code that it applies to. So the changelog will tell you some of that, but it is not condensed. It is not testable form, those kinds of things. This creates the testable form. We condense that stuff down. Okay, I hope that answered that question. Here's a terse low-level requirement example. Here's all I'm doing is just summing 1 to 10, adding the even, so it should be 30.
Reason why you're not doing share like slideshow,
I don't know, which one is it?
it's right to the top, right,
This one right here? All right, cool, thanks.
slideshow, basic bigger.
Oh, I appreciate it. Is that better? Okay.
Got 5 minutes.
Okay, I'll be quick. That's an example. I didn't calculate the hash keys of the ID. By the way, when you first create the requirement in the beginning, rec ID and hash key will be the same. Obviously, hash key is the one that will diverge. This is just an example. So I said it's part of the integer math subsystem, and then I wrote a very terse low-level requirement. I don't think this would actually. I think this is actually too vague for what highest levels of specificity are required. The function shall return a 32-bit signed integer that is the sum of the even 32-bit integers in the inclusive range of 1 to 10. Okay, that's a very terse example.
Just for a quick comment on formatting, I think having to like, instead of putting sysprime text, sorry, type over and over and over again, can you just have like a start and that way you get rid of?
I can, it just kills the ability to do a grep -r and get everything for free.
Well, you may have to do send.
I understand that. I was trying to keep it simple.
The reason why is because having that inside the code, that will be, that's just.
That's fine. I can do that. We can talk about those formatting rules.
You can find stuff with grep, but it's not on every line.
Yeah, -A and -B, right? You can do before and after. So, all right, I was trying to be simple about it.
And you
Okay,
can do pattern match.
Yeah. I'm going to the verbose example next. Okay, good. Yeah.
I think should as we are creating a community around space, should start adopting this one to help this project.
It would help a lot. Yeah.
Yeah, also, I thought about creating a new target, the make file of the kernel, like a make legal certification. Then it will automatically then dynamic generate this documentation inside the code and then print or output dash whatever you want. So we don't mess up with the kernel source code for the engineers.
It can't write the requirement for you. That's a human has to do that, but it can certainly slam the templates in place where it thinks you might need them, but it won't always be accurate.
I think you want the engineers to be able to see it, right?
Okay.
So let me show you the verbose example. This is a much more verbose. I think this is actually too verbose even for aerospace, but I need to talk to some experts who are way smarter about this than I am. So the function is the same function. And this isn't formatting using the rules that I described. The function shall initialize a signed 32-bit integer sum to 0. The function shall iterate over all signed 30-bit, all over 1 to 10. You can read it yourself. But that's a much more verbose version. But what you see here is actually this is 1, 2, 3, 4 separate requirements, all of which are testable. Okay.
I hate to throw some word, this can replace the kernel doc description side, like, but. What is the kernel doc description, like say requirements, start requirements, so inside kernel doc.
That's fine. It just has to have the elements, the hash key and all that to know when you have to update.
Kernel doc already has things in there that has to be automated.
Yep.
To be pulled out, like now return statements has been added, things like that.
None of which we can use for requirements. That's not a testable application.
But the description side,
Correct.
Now define how to make a description side of that using the requirements.
I'm worried about that getting confused. It's a description is not a requirement. So
Yeah.
that's why I said I wanted to be really careful about marketing, SPDX rec, that kind of thing said, this is not just a description.
So you have like a description that's.
Yes,
The normal description,
Yes.
below that requirement, inside the kernel doc.
I'm perfectly happy with that if that'll be accepted. They are not the same thing.
Yeah, no, I understand.
Okay, anyway, that's a verbose one. I think it's too verbose even for aerospace. And then you want to talk about semantics and stuff like that?
Yeah.
Let's jump to final steps.
I don't
It's up to you.
So, yeah, we captured some idea for the semantic aspects to be captured as part of the text section of the requirement. Now, indeed, I mean, the point here is to capture what is the expected behavior in a way that is testable. And this is, both for the developers as well as for the integrators. And the idea is to extend and refine, the current, the design documentation guidelines that we have today in the current kernel docs, writing kernel doc comments. Now here, I don't think we have time. So, but here what we did, we captured, what are the possible elements that impact the expected behavior. And after that, we have the design elements that are impacted by the expected behavior. So it would be important, to describe both of these, for each, for the code that we aim, to write requirements for, so that, it is also possible to unambiguously, define test cases. And this is a bit more important. So, I mean, testability consideration. It is, important to document allowed or not allowed ranges of values, corner cases, and error conditions, so that it is possible, to define meaningful test plan according to the different equivalence classes. Scalability consideration. So whenever we write requirements, this should only be limited to the scope of the code that these requirements apply to. The behavior of the dependencies that should be described in the requirements allocated to the dependencies. And the last one probably is the one that Stephen loves the most, so the feasibility consideration. So only meaningful and useful expected behavior should be documented, in my opinion. So because here we are in a situation where code comes first, and we are trying to reverse engineering the expected behavior by looking at the code. So if we like the verbose example, in my opinion, that is a bad one, very bad one, because it will be easier to read the code. For me, it is faster to read the code than reading what Sharp wrote as a verbose example. And instead here, it is important that we have the Linux experts to play a significant role in either writing or better reviewing these requirements propositions, so that they make sure that the meaningful and useful expected behavior is documented. Only that. As an example, a print key logging in a specific context of a certain function maybe doesn't play any role, right? So maybe we just need to test print key to not mess up with the rest of the kernel address space, for example. But other than
I
that,
think 90% of the time, it's going to be someone else that writes the requirements. And it's because one thing is that I don't know any of the any kernel maintainer that would complain about better documentation.
Right, but they don't want to do it.
Right.
And that's okay. If we have a good accepted standard, you're gonna draw in people who are like, oh, good, this is where I can put those. Yes,
Yeah.
absolutely.
Another comment on the verbose thing, it's not just this too verbose, I think you want to be careful not to specify how it does something, but focus on the behavior. You could switch the language, for example, we have code written in C, we do something in Rust now. In C, you iterate, but in Rust, you do an iterator, a single function call. I don't think you want to prescribe it. You just want to focus on the behavior.
Or even say what the variable names are. We don't want to do that. I was just trying to show the extremes. Yeah.
so
Last slide.
yeah, last slide. So technically, what we do is we envision, we want to demonstrate feasibility, okay? And for doing that, we want to start using, experimenting the template on a target subsystem. Also, we would like to propose changes to the Linux kernel documentation in order to introduce this template and improving, and changing, the documentation guideline to also adopt such a template. And for a long-term goal, we want to scale to other subsystems. Right.
Let me add one comment here.
Yeah.
The ask is, it's like, I'm willing to put my time and effort into this. But the ask is, can I please get feedback from people who, like kernel developers, people who can sort of channel that thinking. Is this feasible? Where is it break? I need your.
So right now, we're actually at the tab, we're talking about better documentation of the system. So if we could tag this onto documenting everything, because we're looking at how do we.
Where do I need to buy my plane ticket to? I mean, all these.
Okay, so there's that meeting tomorrow, which
Oh,
I'm
good.
driving home.
Good. Okay.
So I can't join.
Ah,
Unless, or it's happening
Just inside the road.
or
Yeah.
it's at 2 o'clock Eastern. I'm like thinking that, so, yeah.
Maybe pull off to the, some
Yeah,
up side of the road and find a
Starbucks or something.
Starbucks. Yeah, Starbucks is always a good one.
Maybe I'll try to see if I can find something.
I want to, I mean, we're writing a paper
Right.
because there's a lot of nuance here. You saw everybody jump at stuff.
So no, actually, no, because this is actually time, we focus this on documentation, especially, okay, my OCR, OKR. for
Yeah,
next year
okay.
Is, part of it is the document the Linux schedule.
Oh, good.
And we could kind of tie this into
Yeah.
that.
If we could. Excellent.
Sorry, document and perform testable expectations.
No.
Yeah, no,
Not the same-
basically, no, he
Document to no,
he has to do it.
no, document it to understand what it's doing.
Okay.
Why it's
Right.
doing it.
Higher level.
But we
Yeah.
can, like I said, if we can tie this into that effort, or, and also you have people who actually help define it, and that
Right.
will actually,
What can I do to help you?
Yeah.
Tell me how I can get involved. Okay?
Two things. One, your line number thing, would probably be usable by the testing community. Because there's a lot of people who for years wanted to have something that would indicate what tests are associated with what lines on which of the
Right.
kernel, so they know what tests to redo.
Yeah.
So there's an overlap
Back
there.
in that line?
the line numbers, no, yes, but the.
Well, line number, the indication of what code regions are
Yeah,
affected,
yeah.
affect a particular.
Right now it's proximal.
Right.
It's like, I don't mind putting a code comment in there, like, start end, like this requirement, required beginning, requirement end. And that thing changes.
Proximal works probably. proximal.
Anyway, but I'm just saying that there's another community that's interested in identifying code regions and associating them with tests.
Yeah.
And so that's a good community to talk to.
Yeah.
The other thing is that the best way to get feedback is to throw it out there.
We're going to.
Put,
We want.
find
Yeah, right.
4 places in the scheduler to put this in and put it in.
Well, yeah.
But Stephen, but
I
just
just.
follow up on your thing, we actually are affiliating Kernel CI with Elisa now. And so we're gonna be working tightly with because they need it for figuring out how to do better testing.
Right, yeah.
And so maybe we check the scheduler area and find all scheduling tests and then we get requirements and start showing the linkage. And basically doing the linkage with the requirements linked
Yes.
on through Basil, so that we can start to show the full vision pulling together here.
Right.
And if we can start to show that, then we can, basically start to see the powers. of the-
And I don't want patches to show up on mailing lists, like, what the hell is this? So
Yeah.
if I want to roll it out like this, you tell me where to go from here. Like, we will do work and we will do patches, and all that. Who should I send them to without, so things don't explode?
We've got a few maintainers that said they would
Right.
like it.
That's right. Yes, that's
They
what I want to get out.
have a business goal for doing documentation of the scheduler. So yeah, this lines up nicely. So-
Testable expectation doesn't fit with everybody's understanding of that.
You should just submit it and pretend it was an expectation.
But I get a reasonable response, right?
Yeah, it's like, what do you mean you didn't see this coming?
Well, requirement is just a new concept for a lot of people, so
Yeah.
testable expectations, that's the same as
Make
documentation.
sure you make Linus aware of this.
Yeah.
That's- Actually,
She has.
and Thomas,
Yeah.
Thomas, like, remember from the,
Yeah.
so Thomas is basically doing a lot of getting this up there, technical debt reduction.
Oh,
Part of technical debt reduction is understanding what it should be. doing. And a lot
Then
of
we can
times,
test it.
and then we can get to the high quality level,
Yeah.
which would be a good thing for the kernel overall in my mind.
By the way, also, code that is matches intent doesn't mean it's well designed.
Yeah.
Right.
You still need higher levels of architecture to tie it together. Yeah. Okay.
So very next step, we'll hear from you, Steve.
I'll pick this up if I get a chance to stop tomorrow and things.
Yeah, and point us at the files you want us to take the first crack
Yeah.
at. Okay, documenting the requirements, which ones do you think you've got?
If you want to do it under the radar,
Uh-huh.
do F trace.
Okay,
Direct trace,
Seriously, no one will care.
I will take it. That's right.
well, direct trace.
You accept my email, I'll send you.
No, no, you do it on the list.
Might be a lot of people.
Yeah, but-
As a maintainer.
Yeah.
Okay. Sounds
Better
good.
plan. Cool. Well then. Anything
Thank
else
you
to
for
say?
your patience and great questions.